Rewind life? Yeah, rewind life. So we can record it. Thank you, sir.
Okay. Did Santa come in the football game yesterday?
Yeah, probably.
Did you notice that I have an option?
No, it's bad.
Was that serious?
40 nothing.
I thought that was a joke.
No, I just didn't know.
Our team or theirs?
Basically, a lot of football players aren't in school today.
That's
Why?
true.
What happened? Why was it so bad?
We
Because
suck.
we have a bad football team.
Oh.
Are you recording
Wait,
right
wait,
now?
wait, wait.
They fumbled it out the back of the end zone.
And they get like these little stickers. I gotta be quick. They get these little stickers that they put on their helmets, like if they do with like these little eagles.
Was he ripping the stickers off of the
No.
helmets?
Yeah.
He gave them the stickers before the game and said like you already won this.
Oh!
Oh, that's sweet.
No, before the game and they lost,
And then he took them back.
Awkward. That's weird.
Yeah, it was bad.
Yeah.
The way
Okay.
that the football players are describing it is that every other team is a varsity team and we're just like a baby team.
It's
Aww.
really funny to watch.
Sad. Or it's
really
because
fun.
last year we had like a varsity team, we had good
Yeah.
players.
Yeah, we still weren't.
But we had like legit players and
What are
now
you doing,
it's more
Zach?
like it's
What
very
were we
no-
last year? 4
Give Eric the video. Just kidding. Seriously, stop. Don't do anything bad.
I'm not.
You're just in the picture.
Yeah, but what?
I like Eric better because he just films us on the board. Just kidding. Just
I
giving you a
want
hard
you
time
to
for
do
no
it.
reason.
Okay.
That stinks. Oh well. Who really cares about football anyway?
Washington doesn't
Alright,
make it to
just
the
kidding.
playoffs yet anymore, so I'm happy.
That's good.
Yeah. I hate
Okay.
Everybody should come and watch the draft.
I like your shoes, Zach.
Thank you.
Alright, here we go. What?
That's like kind of.
Yeah, right. Like math. Alright, so I'm going to start just a little bit about inverses for a second, like in general, before talking about the actual derivative of them, because this just stuff gets kind of wacky. And I'm going to actually write these couple sentences that I think should go in your notes, because for me this is a difficult concept. So if it's hard for me, it'll probably be hard for some of you. Okay. Fact. There is a tangent line.
Bless you.
To, I'll say the.
Thanks.
Okay. I should say if, sorry. God bless you.
Thanks.
If there is a tangent line to the graph of f at a comma f of a, then there is a tangent line to the graph of f to the -1. We did that yesterday, didn't we? Like the notation for inverse is f to the -1.
Yes.
Yeah.
And that does not mean it's a power of -1. Okay, that just denotes that it's the inverse. Yes. Okay, if there is a tangent line to the graph of f at the point x, or a f of a, God bless you, then there is a tangent line to the graph of the inverse of f at f of a, comma a. What's that? That seems obvious, but it's really important. Also, told you I was going to write a lot. The slopes of those tangent lines, the one of the f and the one of the inverse of f, are reciprocals. Erica. Wow. Okay. Alright. In addition to the regular function has a tangent line at a, f of a, the inverse has a tangent line at that same, but f of a, comma a. Also, the tangent lines of f and inverse, so the inverse of f, have reciprocal slopes. Okay, if I were being honest, which I always am, in past years, so I'm teaching this for like 7 years, in past years, I just kind of skimmed over this whole inverse thing and like didn't really explain it because I never took the time to actually try to understand it. This is the first year I'm like, okay, let me make sure I really get it. So hopefully you will really get it this year. We don't have to just say like, inverse is poof, we don't know what we're doing. So the idea is this. Let's say f of x, let's take an easy function first. Let's say it's x to the third. And let's take a point on that function, and I just made up a random spot, 2, 8. And let's just look at the derivative of f of x at that point. Easy, no inverses yet. So the derivative of f of x is 3x squared, and evaluated at x equals 2 is what? 12. Okay, so if I look at the function, an original function, and I take its derivative at a certain point, I'm taking this function, I got 12. Now let's look at the inverse of that function. What's the inverse of x to the third? What undoes x to the third? Cube root. Okay, so the inverse of that function would be the cube root of x. Anyone remember how to find what that is? Like if it was more complicated? Do you remember how to find the inverse of a function? Switch x and y and solve for y. So I could switch, make this x and make this y, solve for y, and I get the cube root. So that's how to find the inverse, but we can really easily figure out that the inverse is the cube root of x. Okay, so let's find the derivative of that. The notation for the derivative of the inverse looks like this. It's the inverse, parentheses, derivative sign, parentheses x. Okay, that denotes the derivative of the inverse. So the derivative of the cube root of x, well, this is the same thing as x to the 1/3. So it would be 1/3 x to the negative 2/3. So I'm going to put that on the bottom. Right, if we take the derivative and we subtract 1 from 1/3, 1/3 minus 3/3 is negative 2/3. So that goes on the bottom. Well, it's a little bit different now because if the point of the original function was 2, 8, what's the point for the inverse function?
8,
8, 2. So if I want to plug in kind of this respective value, I don't want to plug in 2, I want to plug in 8. So you want to just keep in mind this idea that inverses and functions have switched domains and ranges and also switched ordered pairs. So now if I plug in 8, so 8 to the 2/3, what's the cube root of 8? 2 squared is 4 times 3 is 12. So I get 1/12, which is what I should have gotten. Okay, so the tangent lines of f and the inverse of f have reciprocal slopes. So this was an easy example to kind of show that that's true, that if I have a function and I find the derivative at a point, if I take its inverse function and find the derivative at its inverse point, I'm going to get reciprocal slopes. Okay, is that okay so far? Alright, that's all the information that I have, but the problems get really weird. So let's look at what a problem would look like. And this is one of those things like, in the book, there's only one problem in the entire book like this. I don't know why the book doesn't like focus on it at all. It is on every AP test I've ever seen. And it's well, it's not that easy of a problem, but if you know what you're doing, it's not that bad.
Didn't we have one for homework last night that was like that?
Was it 19? What, did it ask for derivative of an inverse?
No, but it like,
I think that just asked for a...
the two equations you got were like that.
Were they? Oh yeah, you did. You did get 2 1/2. I guess so, because number 20 and 21 are the two like this. So, all right. In fact, this one is number 21 in the homework section of this section. 21 and 20 are really the only two that I could find like this. But like I said, it's always on the AP test, so that's why it's worth doing. I think in other years, because the book didn't highlight it at all, I didn't really, but it just keeps showing up on the test, so it's worth highlighting. What's that? I know, right? You never know. You never know. Okay, so say this is f of x. We're going to be asked to find two things. First, find the inverse at 1. And then find the derivative of the inverse at 1. Okay. I'm sorry that I'm really bad at this. I'll do my best. If they want you to find the inverse of the function at 1, this 1 is an x value for the inverse. So it's a what value for the original? It's a y. So I'm going to write this down. So 1 is an x value for the inverse. Therefore, 1 is a y value. For f. So if they want me to find the inverse, the value of the inverse at 1, all I have to do is take the original function and set it equal to 1. Plug in 1 for the y. And find out what x is. Because if I can find out what the x value was here, then that's going to be what this value is here. I don't know if that made any sense. Since 1 is an x value for the inverse, 1 is a y value up here. So I'm going to take 1 and replace it for the y value in the original. And I'm going to solve that. How would I solve that? No idea, right? Your calculator. So there are some you just need a calculator for. This would be one of them. How would you solve it with your calculator? The calculator, I feel like, is such a useless tool until all of a sudden it's like extremely necessary, and if you don't know how to use it, you get stuck. So if I was going to use my calculator to solve this, I can do one of two things. You can either put this into the y1 and put this into the y2 and find their intersection, or you can put into the y1 cosine x plus 3x minus 1, get everything to one side, and find the zeros.
An easier way.
What's that?
You can plug it into the y1 and then go to vars, y functions, and then at the home screen just put in parentheses 1.
Oh, they let you do that?
Yeah.
For the y?
Yeah.
Oh, wow.
Pretty sure.
I think
Yeah,
it
it plugs in 1 for x. That's
But
what I'm saying.
But we're plugging it in for y.
We already have 1 for y. Trying to find x, aren't we?
Yeah.
But why would you plug it in for x if you don't have x?
I don't know.
Yeah, so like you can't go to your table or anything and plug in 1. We're trying to find out what x values this happens at. So, kind of back up. When you have an equation like this, you can either put 1 in the y1, 1 in the y2, find the intersection. I usually put everything on one side and find the zeros. That seems to work the easiest for me. So when I do that, do you want to try it on your calculator, or can you do it? Try it, just make sure. Make sure you're in radians. Oh. Like, putting it in radians is so freaking hard.
It's annoying.
I almost failed my physics test because my
Really?
calculator was in radians.
Luke, that's not why you almost failed your physics test. Gotta tell you. Just kidding. his calculator. I'm gonna be scared. People who did it, what did you get?
0.
0? I got 0. I did not get a strange value, I got 0.
That should have been so much easier. Yeah, calculator for that. I just thought about it.
Yeah, I mean, if we just thought about it, cosine of 0 is 1, and that would be 0, and it would work. Make sure you get it. If you just did your calculator and you didn't get it, figure out why, or ask me to look at it.
The X value, right?
Cosine x plus 3x plus 1.
I don't know either.
No, it makes sense because we moved the one to the other side.
Mine's 0.
You know what that is 0.
6
Because it's scientific notation, it's 0. Yeah, so whereas this e to the negative 15 means it's in scientific notation for some reason, and if you move that decimal point back 15 places, it's 0. Some calculators are really weird.
Bigger than 0. My calculator's
Yeah, I don't know why.
That makes
See,
sense.
Eric doesn't do that.
Yeah, I don't know why that happens, but it does. Alright, so anyway, back to the point. When you solve that, you should have gotten 0 for x, right? So that means, this is kind of how I set it up. In f, we have a point at 0, 1. In the original function, we have a point 1, 0. Okay, do we agree with that?
Yeah.
So the first clue to getting this kind of problem solved is finding what the point is for the function, what the point is for the original. So what they're trying to get, was that Abby? Hi, Abby. What they're trying to get you to plug in is a y value for the original. So we're taking the function, setting it equal to the 1, and finding the x that goes with it. So that x, y is for the original function, flip them, that's the point for the inverse function. So when we go to find the derivative of the inverse, we just showed in the last example that the derivative of the original and the inverse are just reciprocals of each other. We're going to go take the derivative of this. Negative sine x plus 3. And instead of plugging in 1, so you kind of almost want to plug in 1 because that's what I'm finding the derivative at, but this is the derivative of the original function. So instead of plugging in 1, I want to plug in the x value of 0. Because it goes, that's kind of how the original function works since I'm looking at the original. When I plug in 0, what do you get?
3.
Oh, do I? Oh yeah, that was done. I get 3. What do you think, if you had to guess, is the derivative of the inverse then?
1/3.
Yes, 1/3. Did that confuse the crap out of you?
Yes. Well,
Yeah, a little bit.
kinda. I wasn't.
Awesome.
So you solve for the slope of the.
So first we took the value that they're giving us, which is an x value for the inverse. We want to find what goes with it, because when we take the derivative of the inverse, we're looking to plug in, this is an x value for the inverse. Well, all we have is x values for the original. So we got to find the x value to plug in, and it's not 1. It's the point that goes with that 1. So I almost think you maybe want to memorize the system here, even if you have trouble conceptualizing it all. Wherever they're asking you to find the derivative of the inverse at, that's a y value for the original. So take the original equal to that and solve. Whatever you get, that's the value that you have to plug into the derivative of the original and flip. And that's your final answer. The problem's going to get no harder than this. It's going to be like this exact same thing. So let me go through that one more time. The thing that they're asking you to plug in, instead of plugging that in for any x, you're going to set the original function equal to that. Solve the original function, and whatever you get, you plug it into the derivative of the original. And then for your final answer, flip that. Did you get all that?
This is so much easier than related rates.
No way.
I think it is.
This understanding it, I think, is very complicated. Performing the tasks isn't that hard. But then it's like a memorization thing. So let's do one more. I know I said this was gonna be short. It's not that short, is it?
We're gonna have time for taboo.
Tornado.
We can stay.
If we just do one more example.
We can stay after.
If it's only one.
Yeah, most of us can stay after.
No one has any priorities other than
Really,
So Billy's game.
taboo is always a top priority.
Hey, Oliver, want to take me home too?
I'll stay after if you're gonna take me home.
I don't want to take anybody home. Road trip for all of a sudden.
Okay, so I set this one up in my notes a little bit more linearly, like step by step. So the first thing you're gonna do is take 21 and do what with it?
Plug it into y.
Plug it in for the y. Set the original equation equal to it. So 2x to the third minus 4x squared plus x is going to equal 21. Some problems you'll be able to do without a calculator, some you won't. This one, without a whole lot of trickery, is going to take a while. So I put it in your calculator. And when I put it in my calculator, I got x equal to 3. Okay, so we know on the original function, on f, we have a point at 321, and on the inverse of f, we have a point at 21, 3. Everyone agree with that? So what they gave me was an x value for the inverse is a y for the original, so I plug it in for the y in the original and solve for x. So that xy is an f, flip it, that xy is an f prime. I mean f to the negative first, the inverse. Okay, the second thing we're going to do is we're going to take the derivative of the original function. Because we know that the derivative of the original function and the inverse are just reciprocals. So we're going to take the derivative of the original and get 6x squared minus 8x plus 1. And what am I going to plug into that?
21.
3.
3.
Oh my god.
Okay? That was the whole point of setting this equal to 21, was to find out what to plug in. Because 21 is an x value in the inverse. So it's a y value in the original. So when I have the original, it's in terms of x's. I need an x value to plug in. So I got to plug in the x value that goes with the original function. When I plug that in, I got 31. The third thing to do, to find the derivative of the inverse, flip it. That's it.
Taboo!
I get it. Yeah.
So, to do it a harder way, would it be? Just to understand the concept.
Yeah.
If I took the inverse of the original function, took the derivative of that, and plugged in 21.
You should be fine.
Okay.
Yes. The only problem with that is the last one, and even this one. How are you going to solve that? Like
Well,
if you
no.
take the inverse and you place x's and y's and solve for y's, you can't solve that for the y's.
I know, but just for like,
Right, for understanding's
Yeah.
sake.
For the
I should
shiggles.
have said that. I should have said that. If we could find the inverse of this and then go separately and take its derivative and plug in 21, you'd be fine. But we can't find the inverse of that because we can't solve for y. Yeah. And same with the one before. That would have been tough to solve for y too, because it was cosine and it was a 3y or whatever the heck it was, 3x. So that's what kind of why I should have led with that.
We're just finding the slope of the original function and then switching it.
Yeah, but you're finding the slope of the original function not at this x value, at
Oh, yeah.
the x value that goes with it.
That's because they give you the derivative.
Suyan, you're wasting our precious taboo time.
All right, this is the best I can offer. I hope it's okay.
As long as we get taboo.
There's only one homework problem. Number 20.
Doesn't matter. Let's get taboo going.
Still in the same drawer.
Something's easy.